Hey, how's it going, everybody? All right, we've been talking about parallelograms for the last couple of sections, and now what we're going to do is start focusing on what are actually special kinds of parallelograms: rhombuses, rectangles, and squares. All right, and the goal here is that you will use properties about sides and angles of rhombuses, rectangles, and squares. In another video, we'll go and throw in properties about diagonals. You'll learn those about parallelograms. You're going to learn them about these shapes as well. And what I'd like to do is this basically in the video. I'd like to go through and talk about what is a rhombus, what is a rectangle, what is a square, and then what are a couple of things that you can do in terms of solving problems that will take advantage of the properties that each of these figures have. All right, a rhombus. Now, I've got a picture of a rhombus over here, and I think by picture, most of you recognize what a rhombus is, and you might be able to describe it pretty well. And I'm going to describe it before I write down a definition. Essentially, what you know a rhombus as is a quadrilateral in which all the sides are congruent to one another, right? Now, you might say a square has all the sides congruent, and you're not incorrect there. But the most basic way of thinking about a rhombus is that it's a parallelogram, maybe, that has four sides that are congruent to one another. Okay, now I just mentioned the word parallelogram. Whenever a quadrilateral is equilateral, it turns out that it has to be a parallelogram. Why is that? Well, isn't this one pair of opposite sides that are congruent, and here's the second pair of opposite sides that are congruent? If all four sides are congruent, then you've got two pairs of opposite sides that are congruent, and that makes a rhombus, or an equilateral quadrilateral, a parallelogram. And so that is the definition that I'm going to write. A rhombus is a parallelogram, is an equilateral parallelogram. And one of the things that I really want to drive home in this video is the fact that a rhombus is a type of parallelogram. Now let me kind of explain that a little bit. If I tell you that somebody is a football player, well, that kind of tells you what sport they play, but I can be more specific than that, can't I? Aren't there special types of football players? For instance, there's the keeper. If I tell you that somebody plays keeper on a football team, you know a little bit more about them than if I just told you they played on the football team, right? And kind of a similar thing here. If I tell you that a quadrilateral is a parallelogram, well, it tells you something about that quadrilateral. But if I tell you it's a rhombus, it means not only is it a parallelogram, but it also has four equal sides. Okay, so what we're doing is we're further classifying, or we're finding special types of parallelograms. That's probably the best way of saying it. Finding special types of parallelograms. Okay, now also while we're talking about rhombuses, I want to do a couple other things. There's something in your book called the rhombus corollary that I want to discuss with you. And then I want to talk about what are the properties of the sides and the properties of the angles of a rhombus. Okay, now by definition, a rhombus is an equilateral parallelogram, right? A rhombus is always a parallelogram. But the rhombus corollary basically tells you that anytime a quadrilateral, whether you know it's a parallelogram or not, anytime a quadrilateral is equilateral, then it's a rhombus. Now this is a slight paraphrase of what's in your book. Notice that this is an if and only if statement, and an if and only if statement can be read two ways. This could be read that if a quadrilateral is a rhombus, then it's equilateral, or if a quadrilateral is equilateral, then it's a rhombus. But any quadrilateral that has four congruent sides is automatically going to be a rhombus, and that's what that corollary tells you. Okay, but I said I wanted to emphasize the fact that a rhombus is a special type of parallelogram, and here's where that's going to be important. Because a rhombus is a type of parallelogram, any property that applies to a parallelogram is also going to apply to a rhombus. So when I'm talking about the properties for the sides of a rhombus, it's going to have all the same properties that a parallelogram does for its sides. Okay? Meaning that its opposite sides are going to be parallel to one another, and opposite sides are going to be congruent to one another. Now, if all four are congruent, we've already established that means the opposite sides are congruent to one another. But a rhombus does have one additional property about its sides that most parallelograms don't have, and that is that it is equilateral. Okay? And then when we're talking about the properties for the angles, well, again, since a rhombus is a parallelogram, it has the same properties for its angles as parallelograms do. by which you'll recall I mean that the opposite angles are congruent and all the consecutive angles are supplementary to one another. Now, there's no additional properties about the angles of a rhombus, just those two things that we already know about parallelograms. All right, so that's rhombuses. Let's take a look at rectangles next. All right, now you, of course, know a rectangle as being a quadrilateral that has all right angles, which is a correct way of thinking about a rectangle. Let's go a little bit further with that. Now, if all four angles in a rectangle are right angles, that means they're all equal. Or in other words, this is an equiangular quadrilateral, right? Now, it turns out, just like when a quadrilateral is equilateral, it's a parallelogram. Well, when it's equiangular, it must be a parallelogram as well, right? And easiest way to think about that is, doesn't it have two pairs of opposite angles that are congruent to one another? Okay, so a rectangle, just like a rhombus, is a special type of a parallelogram. And in fact, the definition that I'm going to use is this: a rectangle is an equiangular parallelogram. Okay? Now you have a rectangle corollary like we talked about a rhombus corollary a moment ago. And a rectangle corollary is not much different than the definition. It's just basically saying that any quadrilateral that is equiangular must be a rectangle. Okay, now more precisely, this is still a paraphrase, but a little more precisely, it's written, a quadrilateral is a rectangle if and only if it's equiangular. Any equiangular rectangle or quadrilateral is a rectangle. All right, now again, I'm trying to emphasize the fact that we're talking about a special kind of parallelogram. And so when we're talking about what are the properties about the sides of a rectangle, well, the properties for the sides of parallelograms apply to rectangles as well. Meaning that we can say the opposite sides of a rectangle are parallel to one another. All right, these would be parallel. These would be parallel. And the opposite sides are congruent to one another. There's no additional property that has to be true about the sides of a rectangle, just those two that we already know for parallelograms. However, when we're talking about the properties for the angles, it is a parallelogram. It'll still have the same properties as a parallelogram does. Meaning, as you can already see, that the opposite angles, both pairs, are congruent to one another. And the consecutive angles are supplementary. Isn't 90 plus 90, 180, no matter which pair of consecutive angles that you look at. The additional property is that all the angles are equal. So, it has all the same properties as a parallelogram's angles, but it also has the additional thing that it's equiangular. All right, and then finally a square. Now, you know of a square as having four congruent sides and four congruent angles. So this is what you're used to seeing. And I'm going to make the same point with squares that I did about rhombuses and rectangles. A square is really just a special type of parallelogram as well. Take your pick. Do you want to conclude it's a parallelogram because both pairs of opposite sides are congruent? Well, that's true. It's a parallelogram. Do you want to say it's a parallelogram because both pairs of opposite angles are congruent? Well, you can, because both pairs of opposite angles are congruent. A square is also a special type of parallelogram, and it just happens to be a regular parallelogram, meaning equilateral and equiangular. All right, which is a pretty simple definition to catch on to. I really like the corollary for this one a little bit better than the other two. It's more fun to think about. Now, a square is equilateral, right? Didn't we say that any quadrilateral that's equilateral is a rhombus? So a square is a rhombus. A square is also equiangular. We said that any quadrilateral that is equiangular is a rectangle. So isn't a square a rectangle then? Here's the way the square corollary reads. A quadrilateral is a square if and only if that quadrilateral is both a rhombus and a rectangle. All right, it is possible for a figure to be both a rhombus and a rectangle. Just means it has to be equilateral and it has to be equiangular. And in the instance where it's both of those things, the more precise name for the quadrilateral is that it is a square. All right, so based on that, what can we say is true about the properties for the sides of a square and the properties for the angles of a square? Well, it turns out that the properties for the sides of a square are the same as the properties for the sides of a rhombus. The opposite sides are parallel, the opposite sides are congruent, and all four sides, in fact, are congruent to one another. Then the properties for the angles of a square are all the same as the properties of rectangles, which would imply then that it has opposite angles that are congruent. Consecutive angles are all supplementary because, in fact, all the angles are the same as one another. All right, so now you know the properties for squares, rectangles, and rhombuses, at least for their sides and angles. Let's do a little bit with those. Parallelogram family. Let's talk about that really quickly. I really want you to know the relationships between parallelograms, rhombuses, rectangles, and squares. Now, I got this picture of a family. I think it might get in the way, so I'm going to get rid of it real quick. Never mind, I don't think I know how to get rid of it. So I'm going to work on top of it. What I'm going to do right now is I'm going to make a quick Venn diagram that shows you the relationship between rectangles, rhombuses, squares, and parallelograms. Now, every one of those three shapes that we were learning about today, we said was a special type of parallelogram. Okay. Now, in a Venn diagram, you're trying to draw sets to show the relationships between certain other sets. Okay, and I'm going to draw a big parallelogram here and say that that is the set of parallelograms. All right, and every parallelogram, well, you know what parallelograms are about. Okay, and within the set of parallelograms, there are going to be three subcategories. There's rectangles, there's rhombuses, and there's squares. Now, a figure can be a rhombus as long as it's a parallelogram that is equilateral, right? And then if a figure happens to be both a rectangle and a rhombus, it's a square, as we just said a moment ago. So I kind of put that here in the middle of the Venn diagram. All right, you need to know that a square is always a rectangle, and it's always a rhombus, and it's always a parallelogram. Whereas a rectangle can be a square, but it doesn't have to be equilateral, and so forth. Hopefully that diagram has a little meaning too. All right, now on to the examples. All right, let's say here that for any rhombus, QTNV, we're going to decide whether the statement that's given is always or sometimes true. Notice that never is not going to be an option here, just always or sometimes. Well, one of the things I want to teach you here is about naming quadrilaterals. May have said this in another video, I can't remember for sure, but I'll say it now. Let's draw a rhombus, because we're talking about a rhombus here. Now, whenever I have a rhombus QT and V, I can't just put any of those vertices wherever I want to. All right, they have to go in some kind of order. Now, I can place the first one wherever I want to. Q could be any vertex, so let's say I make it the lower right-hand corner. All right, that's fine. But then after that, you have to name the vertices either going clockwise or counterclockwise in the same order as the name. So I could put Q here, then T, and V. Or I could go Q, then T, then N, then V. I'll do the second one. I'm going counterclockwise here. And the reason why it's important to do that is because then it's easy to look at the name and determine, all right, so it's QT and NV. Would those be consecutive sides or would those be opposite sides? And it's fairly obvious if you named your picture the way I described to you that those would have to be opposite sides. If I wanted to know, is angle T a consecutive angle or an opposite angle from angle N, well, if I've named this correctly, I can see clearly that they are consecutive angles, not opposite angles. And that'll be imperative to us being able to answer this question. All right, so it's a rhombus, so let's just make it an equilateral, quadrilateral right there. And in the rhombus, would segment QT have always or sometimes need to be congruent to segment VQ? Well, in a rhombus, all four sides are congruent to one another. Notice those are consecutive sides, QT and VQ. In other parallelograms, those wouldn't have to be congruent, but in a rhombus, they would always have to be congruent. Okay, now let's deal with the angles. Angle T and angle V. Those are opposite angles, right? Now, we said that the properties for the angles of a rhombus are the same as the properties for the angles in a parallelogram, which means that the opposite angles of a rhombus are always going to be congruent to one another, and that's our answer here. All right, and then would it be sometimes or always true that angle N is congruent to angle V? Well, angle N and angle V are consecutive angles, right? Now, those always have to be supplementary to one another, but is it possible for them to be congruent? Well, yeah, didn't we say that it's possible for a rhombus to be equal angular as well, if it was a square, for instance? So, in the instance that these angles were both 90, it would be true to say that angle N is congruent with angle V. In every other case, it would not be true. So that's going to be sometimes. Easy enough to use these properties, right? Let's do another pair of examples here. In these examples, I'm going to give you two of them. Classify the quadrilateral, explain your reasoning, and then find the value of x and y. All right, the classification part should be easy. I didn't try to fool you with the drawings here, but we want to make sure we use the properties shown, not just the way that it looks to classify. This quadrilateral looks like a rectangle, and why is it a rectangle? Well, we know that 3 of the 4 angles are right angles, and it is a quadrilateral, so you know the sum of the angles is 360. These add up to 270. That means that the third angle is going to have to be, the fourth angle, excuse me, is going to have to be 90 degrees as well, right? So, rectangle because it's equal angular, excuse me. All right, so there's our classification, and then here's our reasoning for that. It's an equilateral or quadrilateral. And then the values of x and y. Well, the rectangle's opposite sides are congruent to one another, right? So we can make 2 equations here. We can say that 5x plus 11 equals 36. And we can also say that x plus y is equal to 58. Now let's use a little what I hope is common algebra sense to you. We can't yet solve the second equation because we don't know x or y, but we can solve the first equation because it's only got one variable. And so you're going to end up finding out that x is 5. And then as soon as you know that x is 5, we can say that 5 plus y is equal to 58. Yeah, ugly 5 there. And so that means y is equal to 53, right? Very simple. One more problem here. All right. There we've got a quadrilateral that is equilateral. All 4 sides are congruent. And it has a right angle. Now, it only has one right angle that's shown. So would this be a rhombus or could it possibly be a square? Well, it turns out that it's going to have to be a rectangle, and let me justify that for you. Since a rhombus has to be a parallelogram, we know that the opposite angles have to be congruent. So if this one's a right angle, then this is a right angle as well. And we know the consecutive angles have to be supplementary. So if that's 90, its consecutive angles are each going to be 90 as well in order to make them supplementary. So even though I only told you that one of the angles was a right angle and it was equilateral, it turned out this was a regular polygon, regular quadrilateral, or a square. So that's our classification. The reasoning is that it is both a rhombus and a rectangle, both equilateral and equiangular. All right, now let's go ahead and set up our equations here. Now keep in mind that all 4 sides are equal. I know expressions for the lengths of 3 of them. In this case, it wouldn't do me a lot of good yet to say that 2x minus 1 is equal to 3y minus 9. That's 2 different variables, isn't it? But it's kind of nice in a square that I can also say 2x minus 1 equals x plus 14 because the consecutive sides in a square are also congruent to one another. So let's make that equation. Then let's subtract x from both sides and add 1 to both sides. 2x minus x is x. 14 plus 1 is 15. We got x is equal to 15. And now I can set either one of these two distances equal to 3y minus 9. Since all 4 sides are equal, it doesn't matter which I pick. I'm going to set the x plus 14 equal to 3y minus 9. Okay, and then we're going to substitute for the x right there. And we're going to say then that 15 plus 14 is equal to 3y minus 9. And solve. You get 3y equals 29, or y is equal to 29 thirds. You could also write that as 9 and 2 thirds if you wanted to. There you go. That's how you use the properties for sides and angles of rhombuses, rectangles, and squares. We'll talk next about the properties for their diagonals. Thanks for watching, everybody.